2 through 4. So those of you who are like me, you love to make lists, you love to check them off. If you go to that target sheet that I gave you at the beginning of the year, you can just check off 3 today. Who's a list checker and you just love, am I the only one in the class? Yeah. Okay. Today I'm going to describe to you density. I'm going to teach you how to calculate density, and then if I give you density, I will ask you to be able to give me mass. If I give you volume, you give me mass. If I give you mass, you give me volume. Okay, so does anyone know the density of water? No? It is the one density that I will expect you to memorize. It is the one. No, it is just one density that I will expect you to memorize.
Is it 1?
It is 1, yes. It is 1 gram per milliliter. That is very important because if you know how many grams of water you have, guess what? You know how many milliliters you have. Jeffrey, if you have 500 milliliters, how many grams? You did that without even a calculator. That is excellent. That is excellent. Isaac, if you have 6.569 grams, how many milliliters do you have? Excellent. Very good. Bailey, if you have 2.3635912 milliliters, how many grams do you have? I don't think that was right. Of course, I don't remember what it was because I just made that up. Try to make it as hard as possible so that Bailey would look at me and go, What is density? It is how much stuff or mass is crammed in a particular amount or volume of matter. It is mass per volume. Or you can say it this way, mass over volume. Or you can use their units, grams over milliliters.
That's what density is?
That is what density is. It's how much stuff is in a certain amount of space. Here are some examples of substances and their densities. Oxygen is only about 1,000th as dense as water. Makes sense because oxygen is a gas. Water, how about this one? Ice, 9/10 as dense. That is unbelievably important, Spencer. I mean, so much of life depends on the fact that the solid version of water is less dense than the liquid version. That is unbelievably strange. Because everything else, the solid is more dense than the liquid. Ethanol is only about 80% as dense as water. Aluminum is 3 times denser. Iron is about 8 times denser. And copper is about 9 times denser. So all those things will sink in water, while anything that is less dense will float. Okay, here I have 2 bricks, a styrofoam brick and a brick. They have the exact same volume, and yet the brick weighs more.
Well, styrofoam's like 80.
Why? Somebody explain to me why. Yes.
The styrofoam has like little pores or something, like it's really airy. Like it's not like.
So what's the difference between a brick molecule and a styrofoam molecule?
The brick is like bam, like all together, and then the styrofoam.
Oh,
Like,
how disappointing.
I
You're absolutely right.
Oh.
I was hoping you would say that a brick molecule has more mass because you saw the brick was heavier. But that's absolutely wrong. A styrofoam, if you were to weigh a molecule of styrofoam and a molecule of brick, you would find that a styrofoam molecule is heavier. So what's the difference? Unfortunately, she's right. It's the fact that you can fit more of these lighter molecules together than the styrofoam. The styrofoam, as she said, has a lot of space, empty space between the molecules. So even though styrofoam is heavier, overall it is less dense because of all that empty space. There's not as many molecules in the same volume. Yes?
Wait, so if you put the styrofoam like the brick and like put all the molecules together, it would be heavier?
It would be heavier, yes.
That's really weird.
If you could fill in these empty spots with styrofoam, it would be heavier.
That's weird. Yeah.
What is the formula for density? Okay. Here it is. Mountains tower over deserts and valleys.
What the heck?
Mountains tower over deserts and valleys. Mass towers over density and volume. In other words, let me change the color. In other words, density is equal to mass over volume.
I remember this.
Now, you guys have a big advantage. Your teacher is probably one of the dumbest science teachers around.
Oh, shoot.
Okay, I'm a great actor. I can act like I know stuff, but I'm probably the dumbest of all the science teachers. So I have to come up with weird ways, simple ways in order to remember these things. So with density, I think of mountains towering over deserts and valleys. Because if not, I won't remember these things. The advantage you have is that I'm just a little bit smarter than you guys are. Just a little. Which means that I can actually relate to you guys. So that makes me a more effective teacher. So because I'm so dumb, I'm a good teacher. All right. So here's the first math question that we're going to deal with. Mountains tower over deserts and valleys. I make it into a triangle. A piece of lead has a mass of 22.7 grams. So I circle mountain, mass, mountain. It occupies a volume of 2.00 cc. So I circle volume. Anything that is given to me, I circle. What is the density? If they ask for it, I scratch it away. What's left should be mathematically what I should do. What should I do for this?
Divide the mass over the volume.
Everyone should be clicking. Tanaya, what do you have, girl? 11 point. How about if we always make it one decimal place? Just standard. 11.4. Thank you, Tanaya. Grams over milliliters. Grams over milliliters. What if she had just said 11.4?
Or it's naked.
The number would have been naked. No units, no credit. 11.4 means nothing in chemistry. It may mean something in math. It means nothing in chemistry. Make sure that when you do these math questions, you always put down units. No naked numbers. A piece of lead. What did we just learn about lead?
Is that right? 2.7?
No,
11.4
it is 11.4.
grams.
That's mass. A piece of lead with a density of 11.4 grams per milliliter occupies a volume. Oh, this is one of those density questions. Mountains tower over, Bailey? Density and valleys. Yes, density, that type of geographic location.
I've been to a density.
You've been to a density. Okay, so what do we know? From the previous question, Bailey, we know. So we circled density. What else do we know? What are they asking for? So Bailey, what do you do in order to find the mass? It's grams per milliliters. Times. What's another unit for cc? Milliliters. Milliliters cross out. Bailey? What? I'm having a hard time hearing you. Can you say that louder and clear? Do you all agree?
Yeah.
Is 45.6 the answer?
No, that's not the little unit.
It's naked.
What?
Milliliters, my dear, crossed out. You're looking for mass. Any questions on this one? There are only 3 types of questions. We have now covered 2 of them. A piece of lead. Okay, what do we know about lead? Emmy? Its density is equal to 11.4 what? A piece of lead has a mass of 302 grams, Emmy. What is the volume of the lead? What do you see when you look up?
Right?
Mountains towering over deserts and valleys. Okay, what are we given? And what are they looking for? So how do we solve for volume? Mass towers over density. And what happens to a unit that's in a denominator of a denominator? It really becomes the numerator. So grams crosses out. The milliliters becomes the numerator. And Emmy, 302 divided by 11.4. Y'all agree?
Yes.
Okay. That's it. I'm not going to make these things tricky. I will either give you mass or volume, in which case you find. I will either give you mass and density, in which case you find. I will either give you volume and density, in which you can, in case you find. All right. Those are the 3 targets. The densest element is gold in a solid form. The densest liquid is mercury, 13.55. Gold is 19.32. Rank the phases of matter in terms of the most dense to least dense. Who is the most dense?
Gold.
Solid except for
Ice.
water. Then comes except for gas is except for no, gang. I mean, it doesn't matter. Gas is always going to be least dense. Period. Doesn't matter in case of water. All right. Why is it so important that water is more dense than ice?
Ice hurts
Ice does hurt. Why is it more important? Why is it so important?
because that's not normally how it is.
Okay, so it's strange.
Unusual.
It is unusual. Why is it so important? Think back to biology. In a lake or a pond or a stream, where does the food cycle begin? At the surface or at the bottom?
Bottom.
So what if water was just like every other liquid and the solid was more dense? Where would ice form first? Cutting off your food supply. As it is, because ice is less dense, it forms. And what does that do for the water below it? Protects it. If it's 32 degrees F on top, it's going to be higher than 32 and prevent the little fishies from freezing. Okay? What about erosion? What part does all of this play in erosion? Before we do that,
Density. Just like all matter, water has physical properties that can be measured and calculated. To find the mass of water, you need a beaker and a scale. First, find the mass of the empty beaker. Then, fill the beaker up with your desired amount of water. Next, use the scale to find the mass of the filled beaker. To find the mass of just the water, we need to subtract the mass of the empty beaker from the full beaker. Our sample is 100 grams. The volume of water can be measured using a graduated cylinder. Our sample is 100 milliliters. Density is calculated by dividing the mass by the volume. Plug in your measured mass. We measured ours to be 100 grams. Divide that by the measured volume. Our volume was 100 milliliters. Water's density is 1 gram per milliliter. Objects with a density greater than 1 will sink when placed in water. Objects with a density of less than 1 will float when placed in water. If a block has a density of 0.1, it will float because its density is less than 1. Another block with a density of 0.5 will also float because its density is less than 1. Notice that more of the block was below the waterline. Another block with a density of 0.9 is also less dense than water, so it will float. We can see that as density increases, more of the block is below the waterline. Scientists have discovered that the block's density tells us exactly where the block will come to rest. If the density is 0.1, then 10% will be below the waterline. To calculate where a block will come to rest, just convert density to a percent. Density also explains why ice floats. If you freeze water, it expands. Let's use the black dots to represent the atoms in water. When you freeze water, no new atoms are added to the water. So because of the expansion, there is more room between the atoms. Compared to the atoms in liquid water, the atoms in the ice are not as tightly packed together, causing the ice to float. So try calculating density for yourself. It's mass divided by volume.
Okay, so why do you think that water is so important when we're talking about erosion? Keeping in mind that all the minerals that we find in soil come from fragmented boulders. Why is water so important? Let's watch this video and see if you can't figure it out.
The ice bomb illustrates the fact that the volume of ice is greater than the volume of an equal mass of liquid water. Some cold water is poured into a cast iron bomb, and a threaded plug is screwed into the bomb so that the bomb is tightly sealed.
Well, the water's all the way to the top.
The bomb is then placed into a dry ice acetone slush, which is at negative 77 degrees Celsius, and will cause the water inside the bomb to freeze. A wooden box is placed over the top of the bomb and slush bath. It takes a short time for the water to freeze. When it does, the bomb explodes. Some of the dry ice acetone slush is blown onto the explosion shield. Little bits of the cast iron bomb are left. When the water freezes, tremendous pressure is produced. The pressure is enough to cause this cast iron bomb with more than 1/8 inch thick sides.
That is a very powerful piece of metal, and yet it was fragmented. Now, why is water's ability to be less dense as a solid so important when it comes to erosion? Raise your hand. Asher.
It'll seep into under the little cracks that it can find, and then when it gets cold, it freezes and expands.
That's right. Seeps into any little cracks, and then when it freezes, it expands. What kind of force is at work at that point? Enough to destroy a large boulder? Give me a little bit of water and a few seasons, and you can break a huge boulder down into little pieces. Why is boiling point and freezing point of water important to the way we measure temperature in science?
So when it expands and when it doesn't. Oh.
What unit is based on these concepts? Celsius. Celsius is based on it. So water will freeze at 0 and boil at 100. We've now completed targets 1B 2 through 4. Your homework is questions 2 and 3 on 1.2.